السلام عليكم ورحمة الله وبركاته. طلاب ماث 342، الله يعطيكم العافية. مع فيديو رقم جديد حبيت أضع العنوان التالي: More Properties of External Direct Products. بداية معنا هذه النظرية في Chapter 4. If D is a positive divisor of n belongs to big N, then the number of elements of order D in a cyclic group of order n is phi of D. You know how you calculate phi of D already. Proof. Let G be a cyclic group of order n. We know that G has exactly one subgroup of order D, say the subgroup generated by B. This theorem called fundamental theorem of cyclic group. Now, every element of order D generates this group. On the other hand, we know an element A power k generates the cyclic subgroup generated by A if and only if a GCD between k and D equals 1. So, the number of such elements is phi of D. As application, we have the following example. Find the number of elements of order 20 in Z100. Solution. Note that Z100 is the cyclic group generated by 1, and the order of this group is 100. Also, 20 divides 100. This, all of these are axioms of this theorem. Note that D divides N, okay, and we have cyclic group of order N, okay, and 20 divides now 20 divides 100, and the cyclic group of order 100. Hence, according to the theorem above, the number of elements of order 20 in Z100 is phi 20, and this can be calculated as phi 2 power 2 phi. And this equals 2 power 2 minus 2 multiplied by 5 power 1 minus 50 power 0, and this equals 8. Next step, find the number of elements of order 20 in Z 20,000. Again, Z 20,000 is a cyclic group of order 20,000, and 20 divides 20,000. Hence, the number of elements of order 20 in Z 20,000 is again phi 20 equals 8. Maybe sometime you know in the last lecture. Now you can calculate. For example, here you know what are the number of elements of order 20 in Z100 is 8. What of them? 8 power 1, 8 power 8 power 3, because it's a GCD between 3 and 20 equals 1. 8 power 3 means 8 plus 8 plus 8. This equals 24. Again, 8 power 7. Yes. And so on. So we have 8 elements. And again, we have 8 elements. The elements here, not as here in general. Next question, Z310. Solution. 20 doesn't divide 310. So there is no element of order 20 in Z310. By theorem, you know that every element, the order of any element divides the group. And 20 doesn't divide 310. So we don't use the last theorem here, but we use another theorem that no element of order 20. So the number of elements of order 20 in Z310 310 is 0. Another subsection, order of an element in a direct product. Recall that if G1, G2 up to Gn are finite group and G equal G1, G2, comma, blah, 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 comma, Gn belongs to big G1 O plus big G2 O plus until O plus Gn, then the order of small g equals least common multiple order of G1, order of G2 up to order of Gn. This theorem we already know. We will use this theorem and the theorem in the first slide. Question. Determine the number of elements of order 5 in Z25 O plus Z5. Solution. If AB belongs to Z25 O plus Z5 with order AB equals 5, this means the least common multiple of order A, order B equals 5. So we have three cases. Case 1, order A equals order B, and this equals 5. In this case, the order of the least common multiple of order A and order B is 5. The second case, order A equals 1, order B equals 5. Third case, order A equals 5, order B equals 1. Okay? So we have three cases. Case 1, order A equals order B equals 5. Now, the number of elements A of order 5 in Z25 is phi of 5, according to the last theorem. And this equals 4. Also, the number of elements B of order 5 in Z5 is phi 5, which is equal 4 again. Hence, the number of elements AB belong to Z25 O plus Z5 such that order A equals order B equals 5 is 4 multiplied by 4, and which is equal 16. Note that the number of elements A of order 5 here 5, here again 5. So the number of elements here and here AB will be 4 multiplied by 4, since the choice of this element is independent with choice of this element. As a multiplication rule in statistics, you know this in statistics or in combinatorics and so on. Case 2, order A equals 1 and order B equals 5. The number of elements A of order 1 in Z25 is phi 1 equals 1. Also, the number A of elements B of order 5 in Z5 is phi 5 equals 4. Hence, the number of elements AB in Z25 O plus Z5 such that order A equals 1 and order B equals 5 is 1 multiplied by 4, which is equal 4. The third case, order A equals 5, so this order notation will be here, and order B equals 1. The number of elements A of order 5 in Z25 is phi 5 equals 4. Also, the number of elements B of order 1 in Z5 is phi 1. Hence, the number of elements A, B in Z25 O plus Z5 such that order A equals 5 and order B equals 1 is 4 multiplied by 1, which is equal 4. So, the number of elements AB in Z25 O plus Z5 of order 5 is first time was 16, second case 4, third case 4, so we have 16 plus 4 plus 4 equals 24. Okay, please solve same question as a comment of this video. The question is, determine the number of elements of order 7 in Z7 O plus Z49. Again, order 7 in Z7 O plus Z49 as a comment, please. Last thing, criterion for G1 O plus G2 O plus up to Gn to be cyclic. Theorem: an external direct product G1 O plus G2 O plus up to Gn of finite cyclic groups is cyclic. This means that G1 is cyclic, G2 is cyclic, Gn is cyclic. The question will when this group, the external, is cyclic, if and only if order Gi and order Gj are relatively prime for all I not equal j and ij between 1 and n. As application, first, Z25 or plus Z5 is not cyclic because order of Z25 25, order of Z5 5, and GCD 25 5 equals 5, not 1. And the theorem said that relatively prime, so must be have the GCD between them 1, not 5. So this not cyclic. Another example, Z2O plus Z3 is cyclic of order 6. The generator, note that Z2 order 2, the order of Z3 3, 2 and 3 are relatively prime, so this will be cyclic. The order of this cyclic group will be 2 multiplied by 3, 6. So this cyclic group of order 6. Another thing, the generator of this group will be generator of Z2 1, generator of Z3 1. So will be the generator will be 1, 1. Another example, Z3 O plus Z5 O plus Z7 is cyclic because note that you have three groups, Z3 and Z5. Order of Z3 3, order of Z5 5. 3 and 5 are relatively prime, or GCD between 3 and 5 equals 1. Again, Z3 and Z7, the order of Z3 equals 3, order of Z7 equals 7. 3 and 7 are relatively prime. Last thing, order of Z5 equals 5, order of Z7 equals 7. And 5 and 7 are relatively prime, so this group is cyclic. What is the order of this group? 3 multiplied by 7 multiplied by 3 multiplied by 5 multiplied by 7. Okay. The generator again will be 1, 1, 1, one of the generators. Okay. إلى اللقاء مع فيديو جديد إن شاء الله. طبعا قبل ما الآن احنا كملت شابتر 4، راح أضع عن e-learning بعض الأسئلة المقترحة عن شابتر 4 وربما أيضا شابتر 8. أوكي، الله يعطيكم العافية وإلى اللقاء مع فيديو